Hello everyone. Yeah, so I'm Varun Kumar Vyas and I welcome you all for today's webinar. And our webinar is on holocore design using PreStress. So we start our webinar in a few minutes. Just wait for attendance. Okay, so I can start with the content over here. Like first we will have introduction. Then we can see some features of PreStress software itself, which covers the following points. Like we can have cross-section ready-made in CAD file that can be imported in PreStress. So if we have different geometry or different cross-section, that can be imported into the PreStress. Then another feature is like sometimes in element there are openings or recesses. So effect of those recesses and the core filling needs to be considered in a design. So how that effect is considered in PreStress, that will be covered in today's webinar. Then next point is due to eccentric load. Sometimes we have eccentric loading in our elements on our elements. So because of that, it creates torsional effect. So that is also considered, and that will be covered in today's webinar. Then also we will be covering fire calculation, and for covering all this point, we will be going through an actual element design from an actual project. So that is contained for today's webinar. So let's first start with the introduction of a company. So Stro Engineers is basically a company wholly owned by Strusoft Sweden. Strusoft is a privately owned Swedish company founded in 2002. More than 25 years of experience in development of software for the building industry, and more than 10 years of experience in consulting. So the development of this software is actually started in 1981 and then supported by Skanska. Skanska is one of the biggest construction company in the world. In Pune office, we have 35 plus engineers who use this software and on day-to-day project basis. So we have the offices in all over the globe. Head office is in Malmo, and the other development offices are in Gothenburg, Stockholm, Denmark, UK, and we have design engineering offices in Pune, India, and another office is in Manila, Philippines. So that's about our uh, availability location wise in the globe. Moving ahead, TrueSoft offers various softwares, as I said. So we have the softwares like WinStatic, PreStress, FemDesign, Whip Energy, and Impact. Each one serve different category. So we will just have small introduction about each one of them, and then we start with PreStress. So WinStatic is nothing but a software which come with a bunch of application. Like there will be 9 application which will be separate application for separate purpose. Like for the design of concrete beam, there will be a small application which can design quickly your beam as per the Eurocode. Then again we have for column, for foundation, for corbel design, and for retaining wall, and many more. So this is a very handy tool to have for the design purpose. Moving ahead, we have Fem Design. This is a 3D software which works on finite element analysis method, and basically it can be useful for design of any kind of structure. As you can see in my presentation, it can design any multi-storied structure to the dome kind of any steel structure. It can design concrete, steel, and timber structures. So in this software, we can do linear, non-linear, dynamic analysis, static and dynamic seismic analysis as per the Eurocode, with all country NHS are possible with the FEM design software. So moving ahead, another software is Impact. Impact is nothing but our detailing software, which is quite useful for modeling the precast elements, and it is also helpful for beam system. Like we have three legs of impact: project management, design, and production. All of three are covered in impact itself. So impact offer you a complete solution in itself. So what I will just brief you about, like in project, what we mean by project. So in the beam system, as we all know, there will be good effective communication by the mean of auto syncing the data on cloud based system. So your model remains at the center of all stakeholders, and anyone can extract the information from that model as per their requirements. So that saves a lot of time, a lot of efficiency in communication, and avoid the potential mistake which may have happened. Moving ahead in the modeling, basically impact is very good compared to other softwares. Like for in modeling of precast elements, it is developed with the feedback of various world-class factories, leading design consultant, and this can work on various platforms. Like it can be in BricsCAD, it can be in Revit, or it can be in AutoCAD. So this gives a good features, so enable 3D modeling very easily and quickly in impact. And as I was talking about the production point of view, yes, you can plan your production schedule in it. You can plan your casting dates accordingly. The drawings will be generated, or production drawing can be easily generated. Seamless connection with machine language is possible. Like in automation, you be required Unitech file, PXML files, so that can be automatically exported from impact. It can generate shop drawings with a 3D model in it, and all the bar bending schedule and the details of casting casting material can be easily uh, extracted from it. So that way it reduces the manual error from the shop drawing and gives you the production efficiency in generation of the shop drawing. So that's the advantage of having impact. So moving ahead to our software, PreStress. So PreStress is nothing but a software which is good for calculation of pre-stressed concrete element as per the Eurocode. So we can design various kind of element like rectangular beam, T-beams, hollow core, flange beam, sloped I-beam, sloped T-beam, and many more. So for designing any kind of pre-stress element, PreStress is software which is good for it. Moving ahead, the best feature of pre-stress is that from release stage to the final stage, all the stages of a particular elements are covered, and the cross check or design checks are performed for that element for all the stages. Like in the release stage, the initial stresses are checked. In the storage stage or in transportation stage, the lifting loads and the lifting points causing the bending moments are checked against the given. So all the points, and as per considering the stage wise, the checks are performed on that element. So that gives us a good hand on each and every aspect of element. Then, as I said, it can design for an fire load case, and uh, that is possible in pre-stress. Then strand pattern manager gives you the possibility to optimize pre-stress configuration. Once you load your strand pattern in it, then you can easily choose and optimize your configuration from it. So that's the feature which I am talking right now. And we can do splitting check, spalling check, and bursting check in pre-stress. Sometimes we have topping. It could be structural topping or it could be non-structural topping. So structural toppings are also can be possible to do with pre-stress. And line load, point load, as I was saying in the starting of the presentation, if we have some point load, eccentric point load, then that effect or recesses effect can be considered in pre-stress. So not taking much time, let's start with the actual uh, problem statement over here. So we will be seeing this problem statement today in pre-stress. If you see on the left side, this is an hollow core resting in grid line E to grid line G, and hollow core 01 we will be designing in today's webinar. So if you see, there is a wall, and around that wall there is a stone cladding. So this is a stone cladding which creating additional load on the hollow core, and that too is centric. So considering that this hollow core is in Norway, so we will consider the Eurocode as a Norway annexure. The hollow core height is 265, the length is 8.364 meter mm, concrete grade is C40, strand is as usual 12.9, and the strength of it. Exposure class we are considering is XC1. Fire we are considering as 30 minute for this case, and there is a one recess, let's say, at this location. There can be any number of recesses, or there may not be any recesses in the element. By the mean of recess is nothing but an opening in a hollow core, or we can say cut out in a hollow core. So here the recess is of size 250 by 300 at this location. So this is all about the configuration of an element. Now moving ahead to the load, dead load case will be the self-weight. Then super dead load will be floor finishing load of 2 kilonewton per meter square. And in the pre-stress, we apply all the load as a line load. So the line load will be calculated first. So I'm calculating by multiplying 1.2 as a width of an hollow core. So it gets 2.4 kilonewton per meter as a dead load. Then stone cladding load will be as a given 50 kilonewton per meter square, and the width is 0.5. So coming out to be 25 kilonewton per meter for the length of 2.2 meter, and the eccentricity is 0.35 meter, and the same with the line load, and the line load category is C. So now let's start with our software. So PreStress have annexures of British annexure, Danish annexure, Swedish annexure, Finnish annexure, and Norwegian annexure. So let's start with the Norwegian annexure. Then it will ask for the name. So let's say hollow core 1. Length is 8.4 meter. Now we select the section. We have predefined standard Eurocode sections in it. Like in hollow core section, if we go, we have different hollow core sections. If we go to inverted T-beam or inverted L-beam, we have different kind of geometries already predefined in it. If you want to add your own, you can do so. Let's start with importing hollow core cross section from an AutoCAD file. So from here, I can go to uh, AutoCAD file, choose the desired location where we have kept. If you have any questions, you can raise in question answer section. So we can, okay, the file is open with me. I just wanted to show you, like, okay, there are various cross sections are in the same file. So I just need is a P line, so I can import it easily. So now if I close it, if I try to, okay, so now you see it has imported only the cross section, and rest all data it will not consider. So that's the good thing with it. So I'll just give it name hollow core 265. Import it, and this will be there in your library for permanent. If you want to remove it, you can do so later. So now, as I was saying, we can do slope T-beam and I-beam. So here we can set up the slope beams. Right now we will be covering hollow core. So let's go back to our case. So no topping over here. We can select the concrete density. Then we add the section. So after adding the section, we see the life cycle or the cases which will be considered for the design of an element. So from the release stage to the final stage and the fire stage is there. So I just need to consider the correct exposure class, and the strength class is already there. Like in the release stage, it will not be achieving 100% of its capacity. So it do calculate it, and then gives us the freedom to change it if we require. So moving ahead after the selection of exposure class and strength to the strand pattern. So here is the view of an hollow core. We can move our cursor and see the sectional view over here. So here, if we want to add the strand, we can add manually, or we can use the layer of reinforcement command. If we select the core value, the cover will be updated based on the country annexure and based on the exposure class which we have given. So let's say we want to have strand 5, so it will give us the strand pattern over there. If we want to have strands in 2 layer, it can be possible to have strands in 2 layer. So that's the possibility over here. So let's say 6 strands. Here I can see the actual xy coordinate. In y coordinate it's 56, in z coordinate it's 42, so that's why it's saying 56 42, and that's the length of an strand, and that is a diameter, and this is a pre-stressing force that we should decide how much is required for that based on design. And coming to the part of material, there is a database over here. If you want to add on your own, you can create new, specify the data, and that can be used for strands. So that's the point for the strands. Then moving ahead, the reinforcement detail. Here we specify the cover to the bottom, to the top, and the side cover, the distance between the layer, and the blue values are nothing but the codal recommended value. If you want to skip them, you can put your own. And if you want to follow those minimum value, you can do so. Moving ahead in the calculation settings, we can decide whether we want to have the punching check, whether we want to have method of shear failure calculation as a standard or advanced method, the shear calculation based on without shear enforcement or with shear enforcement, that can be selected. So moving ahead in the fire case, our fire time was 30 minutes. As per our requirement, we can select fire side is the bottom side, and we can select the concrete aggregate type, and then the calculation sections are nothing but sections, those locations where the calculation will be performed. So all these locations, the calculation will be performed, and then we can see the bending graph or whatever the results we have for these number of sections. If you want to add more number of section, you can do so, or if you want to reduce them, you can do so. But I will recommend to keep the default calculated number of sections. So after the after this parameter, we go to the adding the recess which we had. So the recess is at so now you see there is a recess appeared, and if I just move it, so the section will be updated accordingly. Here I can add the core feeling. So let's say core is 1 0 850. I can select the material for core filling. If I just add, so that can be done. Right now I will remove it. So just we see the without core filling effect and what happened after the core filling. So once we're done with the geometry, then we move to the load case. Here the dead load is self weight is already calculated. So we create other load cases. As stated, is a permanent load. Live. Live had a category C. If you recollect category C. So category C is nothing but for live load. We have different category in Eurocode. So we select which category it belongs. So the load combination will be calculated based on those category. If you have snow, if you have wind, if you have temperature, you can select one of them. So if I just add, now we put a load for a particular case. So for live case, live load starts from intermediate stage after the erection. I can put uniform load, uniformly varying load, or a point load as per my requirement. So if I just specify here 6, just put to the each stage. So I'm done with the live load. Then dead load, which will start from the erection stage. First of all, we will save our file. So okay, so now going to erection stage 2.4. Now we want to apply the stone cladding load of 25 kilonewton per meter with the eccentricity of 0.35 meter and for the length of 2.2 meter. So if I just click on this, so I can see the toggle view. Right now, all the loads are acting at the centroid in the running meter case. So I just specify 25. L0 is start length is 2, 6.2, and the reference is centroid. So if I just specify 350, so it's takes the eccentricity effect. So just select the cases. So our load is applied. I just save it. After the application of the load, we move to the load combination. In the load combination, already by default, the load case G is given with the load combination. Just we need to add another load cases in it. So from erection stage, let's say state, change, emergent stage. As you see, the Xi factors are auto-calculated based on the category which we selected in the load case and based on the load combination action which is mentioned against it. So that gives us the easy handling of load combination. In the ultimate stage, it will calculate the factor. If you have more than imposed load more than one type, then it decide, okay, which will be the main and which will be the following one. So after specifying the load combination, moving ahead to the long-term parameters. In the long-term parameters, we need to calculate the creep and shrinkage coefficient. So we have our portals through soft portal. There we have given a small calculator for the calculation of concrete creep and shrinkage factor. Here we just need to specify basic input like what is the age of concrete, cement type, relative humidity, the concrete cross section, and then we get the result from here. So I have already arrived to them, just I will specify them. If you have any doubts, you can specify in the question answer section. I will answer them. So after specifying the long-term parameters, we are ready for the analysis. So analysis will take a little bit time to complete. So in the meantime, if you don't understand something or if you have any another query, you can raise me through the webinar option is there in Q&A section, and we can take it right now. In the pre-stress, we can perform crack section analysis also. And the one thing which I missed to show you, I can show it over here. Like if you see over here the dependency class. So dependency class specifies that if you have cracks or what we say the effect in earlier stages, that will be continued to the next stages. So that dependency is there, and that's why it is mentioned as a dependency over here. And here we can see the limit stages as a serviceability or ultimate limit stage. So it's in the last case over here, and then we can see the analysis result. Like we can see the analysis result in form of bending moment. Yeah, so this is a bending moment which has appeared right now. If we want to see torsion, we can see so. As we had a eccentric load from this case, so we can see the torsional load. Then the shear force, if we had any axial forces, and deflection. So we can see that, okay, there is a 18.8 mm deflection in serviceability stages and 2.5 mm reduction in support translation in support. So that's if we want to control, then we can improve the strand forces or we can revise the inputs geometry. So it's basically code control system. We give the input and the software calculate backs and give us the result. Don't have to update it. And moving ahead, after having the result, if we want to extract the result, we can extract the result from here, and we can go for design from here. So in the design, it performs the code control, And we have one question over here, like for live loads, how the occupancy time, that is congregation and PSI factors, can be changed. It is inbuilt or need to do manually. You just select the category of a load for the live load, then the PSI factors are selected from the annexures which we have selected, and if you want to change them, you can do so. It gives us the default input, like okay, this will be the PSI factor for this annexure and this category. So if you want to change, you can do so. Hope I answered your query. So now we are done with the design code control over here, and this is a utilization graph which we see over here. uh, I have another one question asking for, do you have any module for Indian code? No sir, we don't have any module for Indian code. We do have only for Euro code for currently. So in the utilization graph, we see that, okay, there is a failure in final stages and in the fire stage. So we can see exactly where is the issue in the result code check. If we go to the final stage, okay, the moment capacity check is nearly passing by 1. The shear capacity is failing. Again, the shear capacity and the shear capacity. So for improving the shear capacity, either I can go for having a core to be filled, or I can improvise the cross section, or can improvise the concrete grade as per my requirement. I'm getting some questions. I will answer them a little bit later. But so so to fix this, let's see the effect of it. But meantime, I'll show you the result, another result, like table shear. If I go 6.10a, so now I see, okay, I am failing in the shear up to the zone of 0.84 meters. So okay, so if we go to the input geometry, and if we add the recesses, like category 3, 850, add, so we do have core filling, and let's see what it makes us affect in our calculation. So uh, so another questions are, hi, do you have any please elaborate on pre-stress laws, how software calculate the same, and does it calculate it vibration frequency? Yes, it calculates the vibration frequency of hollow core element. I will show you in the design report, and I'll come back to you on the another point. So while it's doing its calculation, I can show you the other possibilities with like you can do continuous beam in it if you have a continuous support, and if you want to design a continuous inverted T-beam, you can do pre-stress inverted T-beam I'm talking about. You can do it in the software, and if you have combination of strands plus normal reinforcement, you can do it. So effect of both will be considered in the design. Moving ahead, if you want to add more load combinations, you can do so by defining the different stages by adding by clicking over here, add, give the name to the case, and the case will be added. As here you can see that final stage truck ultimate is added, final stage snow is also added. So different cases can be possible to add in it. Okay. Sorry, I opened that one. So in the same project file, you can keep the different element in a single file. So in this single file, I have designed a double T, T beam, L beam, double T of 5 meter length, and all the file can be kept in a single file of a pre-stress. So that's the best thing which we have with the pre-stress. So now we are ready with the result. We see the deflections over here. Then we click on the design. Let's see For continuous beam, do we have limitation on max number of span, whether the software takes into account the pattern live load? No, the software don't take into account the pattern live load as we are giving the input. But yes, we can have the n number of supports in it for the continuous beam, but we don't have, I mean, the live load pattern itself in it. We have to create it and then we can have it by creating different load cases. So we are finished with the design, and here we see, okay, we are fine with the final stages and we just need to fix the fire case. So fire cases are also sometimes important. We can see the temperature gradient for the fire case at the various sections, and then based on that we can revise our inputs and again cross verify, okay, whether it's okay in passing or not, or we need to fix it. So now we can generate the report from it. I'm going to show you the report. It takes few moments to generate a report. Generally the template of the report is standard, but if you want to customize it as per your requirement, we can do so. Like you can have your own template like project name and, sorry, description and main thing. If you have any questions, you can ask me in question and answer section. I can answer them. This is what I wanted to show you is stirrups reinforcement. We can customize the stirrups as per our requirement. Like I'm reducing the spacing in the initial stage and then I'm optimizing it in further. So that's possible with the software. I'm designing a T-beam over here. So, so the report is ready with us. So here we, first of all, we see the inputs which we have given, the settings which we have mentioned, or the loads, the load combination, and then we see the results for it, and the temperature gradient and design bending moment. Here is the cross-section geometry. Moving ahead, we get the inputs which we have given, the support location. If we had continuous support, then another one will be additional support will be added, specified over here. Then the reinforcement which we have marked in our element, then the load cases and the load combination, then the load which will be applied on that element, and then starts the here we see the eigen frequency for the hollow core. That was the question, and here we can see the value for it. Hope I was able to answer your question. It's in a PDF format, and this report can be extracted. You can save it into your desktop. So here we see the capacity and the forces or the moments acting on it. So we'll just go to the last end point. Back. So here we see the shear capacity, maximum of all ultimate limit stages, and we can see the utilization over here, and this were the load and this were the capacity at that location. So we can fix it, and here we can see the combination in which it is failed. Same with the case of design moment. And here we see the temperature. I have selected the particular section value for this, so that's why it's showing the temperature gradient for that section only. If we select all of them will be printed over here. And the effect of fire on the reinforcement reduction is also specified, how much the effect it had. these are the various stages which we saw earlier. So this report can be saved in PDF format. So PDF format, report. So we have the report with us, and that's what I wanted to show you in today's webinar. And we take the questions if we have any. So we have one question. Can you elaborate on percentage of live load considered for vibration and frequency calculation and checking the same against the limitation? I will get back to you about this as I'm not pretty sure about it. So I can uh, give the answer on mail to you. If we don't have any another question, then hope you liked our webinar. And if you want to have trial version of it, you can contact us on given information. Just mail us, and then we can give you the trial version of it. We have one question over here. How to in will you save this webinar on YouTube? Yes, we will save this webinar on YouTube, so you can see it on later. How to input the moving load? No, there is no possibility of specifying moving load right now, but that's a good point which you asked. Thanks for your time. Same here. Does the software have capability to do slab analysis? You mean solid slab? Yes. If we can do hollow core, definitely we can do solid slab in it. Everything in PreStress can be possible with it. How to see the tendon elongation? Uh, I pretty don't sure how we can see that, but I can get back to you on that point. And all these questions, I will answer them, and will send you the mail to all of them. Like two of them are three questions are with me, like uh, how it calculate the pre-stress loss, and another one is how do we see the tendons elongation and the percentage live load considered. So okay, so hope you guys enjoyed our webinar and it was informative to you. So we look forward to hearing from you. And if you want to have a trial version, you can contact us on the given information.